Excellent. So my name is Gabriel René. I'm the CEO and founder of Versus. I've been in the tech industry working in California and around Silicon Valley for about 30 years. And over the last 30 years in working primarily in advanced R&D, my co-founder and I, who I've also known for several decades, around 2016 started to see the convergence of major exponential technologies start to happen. So artificial intelligence, virtual reality, which now you're augmented reality, which you've seen Apple now bet the future of their devices on, the Internet of Things, which is all the sort of, smart home and smart device and sort of sensors and cameras, which are projected to be in the hundreds of billions over the next decade or so. Robotics. Now we're seeing autonomous vehicles, flying cars, flying drones, able to pilot themselves. And we saw an opportunity to build an infrastructure for this, what we consider to be the next version of the web. And so we did two things. We started a company called Versus, and we wrote a book called The Spatial Web, the idea that the web would move into the world around us, not just sort of be behind the screens, but start to compute in the spaces. So it's entitled The Spatial Web, How Web 3.0 Will Connect Humans, Machines, and AI to Transform the World. I became an international bestseller and still trades in the top 10 in some of the tech categories on Amazon. And we assembled a really amazing company filled with really experts across artificial intelligence, neuroscience, robotics, software, all of these technologies we talked about that we felt were going to be at the heart of this convergence. And from some of the biggest tech companies in the world, people with amazing experience in both enterprise development, software, and sales. In the book, which came out in 2019, we talked about this AI wave hitting, generative AI, which was not even on Gartner's, Gartner wasn't even put this on the Gartner map until 2021, one of the top research firms. And anyway, so generative AI, which is what ChatGPT and the rest here that have blown up in the last 10 months, referred to as generative for their ability to reverse engineer a data set, extract patterns, and then essentially enable you to interact with that data, right? So ChatGPT can ask questions in text, you get text as an output. Others like Midjourney, you can ask questions in text, or sort of give it these prompts and it'll generate, instead of generating text, it'll generate images, it'll generate software code. And this is a little snapshot of Google Trends, which is about the time the book came out, and or about the time we wrote this actually. And you can see the Google Trends on this was like near zero. No one's paying attention to this idea of generative AI. And now, of course, everybody in the world is. The point is, we started building because we predicted that in about 5 years, this convergence would happen, and artificial intelligence would be the thing that is powering the new web. And that's exactly what happened. By Christmas of last year, people are just starting to talk about ChatGPT. Headlines are starting to explode. Investment is starting to fly. And within 2 months, ChatGPT goes from basically 0 users and 100 to 100 million users. There's about 200 million active users now on that platform. They did, I think, I'm going to say $28 million in 2022. They're on track to do $1 billion this year, because everybody now wants this sort of large language models, what they call it, sort of capabilities. And this is an explosion unlike anything we've ever seen in history, even more than what we thought would happen. And so, McKinsey's predicting that this is going to have a 30% impact in terms of growth on the GDP over the decade, $25 trillion impact across every industry. Why? Because AI is essentially an optimization technology. And we're in a world now where everyone's been collecting data, and we're taking that data now. We want to translate it into insights, into understanding, into smart actions. And then we want to automate these things. And so this is the biggest software opportunity, the biggest market opportunity, the biggest prize. And of course, the private markets, the VCs have put about $40 billion into the space in the last year, along with a handful of private investors and a handful of strategics, meaning Salesforce, Google Ventures, NVIDIA. And these are the people that get to invest in these new AI unicorns. And the retail market has zero opportunity to get into this space. And you can get in about 7 years when those companies, the winners, become public. And that 1000x return has already happened for the inside folks that are taking that sort of risk on early technology. Versus is the only company in this generation of AI development sort of software that's in the public markets. Every other AI company in the public markets is a net last generation sort of AI technology. So you see C3.ai and others that are trying desperately to pivot, and I'm sure they'll find their way. But the point is, this prize is not really available for the retail investor. Now, there's a problem fundamentally in the approach that every single one of these AI unicorns that have emerged over the last year, and there's a few others other than OpenAI who did ChatGPT, there's Cohere, there's Anthropic, and there's about 5 that are what are considered foundation models, expected to be the sort of infrastructure that everyone else builds on. And the fundamental problem is that it's even in the name, artificial intelligence. They're taking this approach called machine learning, where they try to sort of build these neural nets, these little processes, and they take as much data as possible, as much compute as possible, and they try to build these algorithms that then try to figure it out. Now, they're only good at really one thing. It's kind of like having a hammer or a wrench or a screwdriver, right? This is considered artificial narrow intelligence. The goal is to have a general intelligence that can learn anything, some sort of algorithm that could understand like humans understand. But that's not what the state of the art is today. And they have this idea, which is called scale is all you need. This is their mantra in Silicon Valley, that suggests that if they just pour enough money, chips, compute power, and data into these systems, that they will somehow achieve this generally intelligent algorithm. And the problem is that this sort of big tech approach with all, and pouring in big data results in a black box. Why? Because the thing's too big to actually understand how it works. It's too complex. No human, not 1,000 data scientists can make sense of this. So they've built something that everyone's using now that they don't understand how it works. And then there are all kinds of negative byproducts because of this scaling of the monolith, one big model to rule them all, which they're on an arms race to try to get to general intelligence, the first one that can basically learn anything and adapt and learn in real time. Today, that's not the case. You got narrow black boxes, and they have a handful of problems because of this. They lack explainability. So if you put this into a system that's supposed to give recommendations for credit or for loans for a house, or whether or not a surgery should occur, they can't explain how they arrived at that decision, that recommendation. And this is a huge concern because it also makes it ungovernable from a regulatory perspective. How do you make this thing align with any set of sort of goals or values if underneath it is inaccuracies? They sometimes lie. Now, they could be 92% perfect, but that 8% could be any critical system, and all of a sudden you've got devastating fallout. They're not interoperable. They don't work together. So everyone's just trying to build their own version. They're all basically using the same data set, which is all the public data from the web, which they're now being sued for by New York Times and a fleet of authors and writers that, because it turns out they used a bunch of copywritten material. And guess what? They can't take it out. It's just this big mesh of data that is, 1 trillion parameters. It's impossible to sort of remove it. And then finally, they don't learn in real time. They're just frozen. So ChatGPT, if you go to it, says doesn't know anything after September 2021. What you get out of this is all kinds of problems beyond that. Bias, misinformation, they can be used for misinformation. They sometimes quote things from people that they never said, and they hallucinate and make stuff up. This is why the governments around the world in the last 6 months have panicked and are rushing to develop AI acts in Europe, in California, in the United States, the G7, all trying to figure out, well, we need these systems to be explainable if they're going to be deployed. We need them to be safe. If they put them in robotic system, we need to make sure that people aren't harmed. We need to make sure they're not hacked. We need to be able to trust these. And so you just had all of the top AI companies up on Capitol Hill in the US last week, sitting with the Biden administration in a closed door session with the Senate, saying, yeah, we'll agree to whatever you guys come up with. The problem is they technically don't have a way to do it. So it's a lot of lip service right now and not a lot of ability to ship. So this big AI approach to intelligence, this artificial approach, the scale is all you need, is really become a problem for them. And here's the CEO of OpenAI saying that the age of giant AI models is already over. He's like, we don't know that just because we build these things bigger, they're going to get any better. In fact, we're not even building GPT-5, and we may not for some time. Now we'll see if this is true, but the point is that the approach that they're taking is not working well for them because of the limitations and the sort of negative byproducts. It's a bit like developing nuclear energy, but you have all this sort of toxic waste. So it's incredibly valuable. There's $1 billion in annual revenue that's appeared out of nowhere. Everyone's trying to use it. Everyone wants to deploy it. Everyone wants the benefits. And these systems are amazing, but the side effects are horrible. And so it's a question of whether big AI has already peaked. So we've seen this before. This is how the personal computing revolution emerged. This idea of supercomputers, these big computers that fill a single room, and IBM and DEC had them, and you'd call in and essentially use the computer, you'd rent time on it. Well, that's exactly what this sort of super intelligence that these the big AI companies are hoping to build. The problem is that's not what won. The minute that someone figured out how to make a small computer that everyone could have, and then you network those together, you have a network of computing, a network of capability that beat the supercomputers to death, right? And now the average 2-year-old is able to connect to that computing network. The web is the biggest computing network in the world. And so, as opposed to the artificial scale all you need approach, we've been taking a different approach. This idea of natural computing. The natural computing is a field of computer science that's derived from essentially biological sciences. It says, how does nature do this? So we use first principles to basically research how nature, how brains, how intelligent systems and biological systems in the world operate. Understanding those first principles and building from there. Nature is hyper efficient. Nature can make sense of things without lots of information, right? You get a glass of water and a banana, you're going to be able to operate for most of the day. Well, very little energy required to do the kind of amazing decision making you're doing. Why? Because evolution has spent hundreds of millions of years on the human brain, billions of years in terms of developing intelligence in life. So this is our approach. The other thing we know about intelligence is that intelligence is networks. It's not one big monolith that you scale to infinity. It's about lots of little things that get connected together. And this is a completely different approach. It turns out that intelligence is actually collective. I mean, you started as a single cell, and now you're about 30 trillion cells to make a person watching and listening and making sense of this conversation. So what you want to build is many little things that connect them. You don't want to build one giant thing, and in part because you have all the problems that you've already seen come with it. So we've been developing a product, which we are now, you're actually the first ones to hear about this in terms of our name change. We've been calling it an artificial intelligence sort of operating system. We talked about these intelligent agents that learn and adapt in real time, unlike the sort of frozen models that are out there. But we've been going through an internal rebranding. We're combining all of our technologies into this single platform, which we call Genius. It's the idea of trying to understand and infuse the genius of nature, how biological intelligence works, into software systems, not just trying to scale compute systems. So with Genius, what you get is this intelligent agent that can learn anything. This is based on an algorithm developed by the top neuroscientist in the world, who's our chief scientist, Professor Carl Friston, who I'll touch on shortly here, who's figured out over a period of decades, and he's on the shortlist for Nobel Prize for this work, how biological systems learn, how the brain actually processes, how neurons actually update their understanding of the world. This can be customized for any use case. You put data in, unstructured data, basically jump in a box of receipts, it will sort through it, make sense of it, model this, be able to build a sort of mental model of the situation, run simulations on that, and then give you the sort of recommended output. So very advanced data analysis, very advanced recommendation system. And then next year, we'll be adding new features around how to do workflows, how to start doing tasks on your behalf, both in the digital space and in the physical space. And so what you get from this approach is that it's hyper efficient. it basically learns in real time. Because of the way that it's modeled, it's 100% explainable. We can transparently see its thoughts, if you will. And this also makes it governable because we can sort of permission which data is available to it at any given point in time and what it can do with that data set. And so it's a shift from this idea of just sort of artificial approach to this natural approach. Instead of sort of big data, one big thing, it's a network of data that gets connected. Just like you make connections in your brain, your neurons actually literally forging pathways that then form concepts and ideas that become the memory that you use to recall or remember something. And that's what our structure is based on. And so it's about taking raw data and converting it into knowledge, making that knowledge actionable. And it uses this kind of mapping structure, this giant mathematical space where it sort of, can log that the reference to Apple in one case is about Apple in a fruit bowl, and the other is about Apple in the tech space, right? As a company. And these agents are also able to be multimodal. What does that mean? It means like, unlike the narrow intelligent agents that are the state of the art today, these can take in text, they can take in audio, they can take in IoT sensor information, they can take in three-dimensional data sets, process information like we do. And these can then be deployed. You can think of this as smart software, right? Genius is essentially kind of smartware that can be then put into anything. You want to make a smart coffee maker, you want to make a smart refrigerator, you want to make an application smarter, have it understand your accounting data. You want to make a personal agent that will be able to interact with other websites and systems, crawl the web and pull information to you instead of you having to go to Google. These are the things you want to put into the autonomous vehicles of the future that actually can learn and adapt in real time, and not just have to compute in a big infrastructure in the cloud, but actually small enough to operate on small devices, what we call the edge. And so what you get is, instead of these sort of narrow, frozen, single-purpose models, you get a like living, breathing, intelligent agent. Now, this is all in software, so we're using these natural metaphors as an analogy. We're not suggesting these things are alive, but they are now able to have general intelligence. This is the holy grail of AI, and this key capability that emerged from the work that we've been doing. So I'm going to punch through the end here. What you get is smarter and safer approaches to intelligent software that understand both the digital and physical understanding of the world, that can understand laws, understand policies, can learn, can reason, and adapt in real time. This is 75 years of computer science, and in this case, what it really needed was neuroscience and biological science to be the lead on it, not just try to compute your way into the future. And so we have actually one of the world's best teams in what's called computational neuroscience from some of the best universities around the world, led by Professor Carl Friston, who is our chief scientist. This is a Wired article from 2018 talking about him as the genius neuroscientist who might hold the key to true AI. This is true. We've proven this. We've demonstrated this. We've put this out in recent papers. One of our latest papers just came out in Nature magazine, one of the top periodicals in the science space about a month ago, demonstrating that the way neurons are processed in a petri dish, how they update their understanding of the world, can be 100% modeled by the mathematical algorithm called the free energy principle. That is a physics-based approach to understanding how information processes that Professor Carl Friston has developed. This is akin to understanding the laws of motion, like Newton did, or a breakthrough almost to the level of theory of relativity. This is understanding the mechanisms of intelligence, which we have built into our software. And we're the only ones in the world that have done this. And we're about to launch over the next quarter here, and the world's going to find out. In addition, we basically, 5 years ago, because in the book, we were very concerned about where this path of artificial intelligence would lead, and into the infrastructure and systems in our homes and our streets and our schools, in operating our financial systems, operating our political systems, that we started working on standards for how to model the data and protect the data that was going into these AI systems. And we partner with the IEEE, who's the largest standards body in the world, standardized Wi-Fi, standardized Ethernet, standardized Bluetooth, to develop these standards for interoperability, explainability, and governance for AI and robotic systems. Anything using data that can operate on that data, this gives us a way to model that data in a very specific way that's explainable, in a way that's interoperable, meaning these systems can then be connected, and the governance of their activity inside of devices, inside of robotic systems. This protects us from the kinds of Skynet scenarios that this artificial path of superintelligence would take. And this is on track to now become the de facto standard for AI interoperability, explainability, and governance sometime next year. We have 100 participants, global participants around the world, governments, large corporations, ethicists, all been working on this for the last 3 years inside of this working group. And our software platform, Genius, is built on top of these standards. So we're the first ones to be able to essentially deploy this along with the algorithms that Friston has developed into this platform. In addition, about 6 weeks ago, we released this report right at the peak of when governments around the world are trying to figure out how do we govern AI. We partnered with Dentons, the largest law firm in the world, and developed this report called The Future of Global AI Governance. In this report, Dentons, whose many of their clients are some of the governments and regulators around the world who look to them for guidance on these kinds of things, they collectively recommend inside of this 80-page report, which you're welcome to read, although there's a 4-page executive summary for those of you who don't have the time, that socio-technical standards that we've developed are the path under which all of the governments of the world that are looking to govern AI follow. And we're already in conversations with congressmen, senators, the AI caucus here in the United States. Through the IEEE, we're talking to the European Commission, who we've been working with for the last 3 years around AI governance with our Flying Forward project of controlling where AI-powered drones could go. So we've tested this already in 5 cities and 5 countries across Europe. And the point is that when we wrote that book and we saw what was coming, we were the first ones to start planning ahead. Essentially, we were like, Noah in the desert, as the rain's coming down, before the rain's coming down, preparing for what we saw coming. So just to kind of wrap it up, this is the G7 on May 20, saying that in order to basically advance AI, the development of international technical standards is required. So they're just figuring it out. We're basically done and ready and kind of here with the solution. So what do you get out of this? You get basically smarter and safer intelligence that mirrors the natural intelligence of biological systems and doesn't just sort of leapfrog the rest of the competition here, but actually our agents are able to use those systems as well. So it helps solve the problems of the current AI providers. So not only are they seen as competition, they actually might be customers. We have a developer pipeline. We've been talking to some of the largest Fortune 500s over the last few years, people that have read the book, that want to get involved, that want to be able to use this technology in some of the most consequential industries around the world. Business model is going to look something like this. There'll be freemium trials. Essentially, it's an API. This is a pipe for developers to be able to build applications on top of. There'll be a 3-tiered structure and then a consumption model. This is very similar to the way OpenAI is doing it. But also, all of those customers of OpenAI are looking for the kinds of reliable data modeling, memory, and steering mechanisms that those systems don't have. So this is actually quite complementary. Timeline looks like this. We're rolling out the beta now, starting in October. Version 1 of the product, which will be in a private beta up until that period. Q2 of next year, we'll be targeting our version 1 of the platform. And we think that IEEE approval of the standards happens right around that time as well, which puts us in a position as essentially the only provider in the world offering adaptable AI that's explainable and governable at the same time. Deloitte picked up the book and put this report out last year called calling this the next era of computing, the spatial web. This went out to all the Fortune 500s, and this is what we've been getting all this inbound C-suite communication from some of the largest corporations in the world saying, we want to use your technology, and we expect to be announcing some of those in our private beta in Q4. Just to wrap up here, the board is made up of some pretty heavy hitters. Jay Samit, who's the former vice chairman of Deloitte. Scott Patterson, who probably many of you know, was the former chair of the TSX, and John DeVos, who ran a $4 billion fund for Invesco. We're currently trading on the CBOE, formerly the NEO, and the OTC in the US. Finally, as I pointed out in the beginning, if you're looking for exposure to AI, if you want to catch this wave, the options you have to be part of the infrastructure level of it are extremely limited, because essentially 100% of the companies that are building this next generation of AI are private. And Versus is the only horizontal provider in the space building next generation intelligence solutions for the future.
That's fine.
Thank you.
Great. Gabe, great job. I actually had a ton of questions from people, but we run out of time. So everyone who did ask a question, sorry we don't get you today. We will get those off to you, Gabe, and then you can get the appropriate person to respond, because there was quite a few questions in there that I thought were very good. But super interesting. What's the name of that book again? Because I think it's just a huge space. There's so much to learn about, and that would probably be a great resource to start.
Yeah, thank you, Arlen. So the book is called The Spatial Web: How Web 3.0 Connects Humans, Machines, and AI to Transform the World. For those of you that asked the questions, I want to make sure we got through a bunch of content today. This is not the end. We're going to be doing a webinar in a couple of weeks where we're going to have tons of time for Q&A. We're going to go through a lot of these things in more detail, but we're trying to keep this as short and sweet as possible.
Right.
Please reach out to us, and we'll put you on that list so you guys can come ask those questions directly.
Awesome. Thanks for your time, Gabe.
Thanks, Arlen. Take care, everyone.